Today, for the first time today, I stumbled on a very strange pattern with synchronization of threads that I never had the same issue before, and I learned a new thing that I was not aware of. So what's the problem? For example, vector sets, vector similarity is not as fast as author Redis comments. So the implementation is by default threaded. You can opt in for no thread. Exactly. But in this case we want it to actually to be super slow. So let's use the truth option in order to perform ground truth and a full scan of all the nodes of the graph. And actually in this case I want to make it slower. I will use filter len equal a len which does not exist. Exactly. Now I get 0.77, so it's slow enough. But in another terminal we can run Redis CLI in latency mode. Okay, if I execute this one, as you can see, this continues to go without problems because it's the first Redis data structure which is completely threaded. So latency is not affected in any way of the server. To do that, I have, of course, threads. I'm using one thread per request, but actually there are a fixed number of slots. So if there are too many threads competing, some thread gets stopped. However, compared to the threading pulse, so a fixed number of threads, the difference is that the command will wait in the thread in this way. And if we have too many threads and the operating system will deny the creation of the thread, we have another path. Okay, the problem is that I have a given key, okay, because here if we go upper, we at some point open this key, okay, exactly, Redis module open key, and then here there is the creation of the thread. But while there are threads that are producing the result for the vector similarity, it is possible that somebody will delete the key. And that's, of course, it's a problem. And then you can think, just use a lock in order to protect the reader. So you acquire a write lock for del, but that's not so simple. Because it's possible that basically the key is here. I create the thread. However, before the thread implementation is, by the way, this one. Till the time that when I create a thread, the operating system scheduler can do whatever it wants. It can run my thread after 1 second instantaneously when the operating system wants. There are no guarantees. So before I am able to lock my object in order to signal that it is in use, in the meantime the del command may arrive and my key is no longer there. The object gets destroyed and so forth. So I had this pattern until today that worked very well, because even if it is an unspecified behavior, it's not allowed by the POSIX threads. Actually, I believe that many operating systems just work with it. So what I did was I locked, I acquired the mutex here before creating the thread. Then I created the thread, and after the thread finished with the work, it was unlocked. So because all the reading threads get the thread in this in use mutex, get this mutex in read only, when I want to delete the object, I needed just to call a function which is called wait for all the background operations, wait for all the background threads, something like that. So when in this case del would block, and when all the background threads finished their work, finally we destroyed the object. And since we can spawn new threads only if we are in the main thread, it is impossible that a new thread is spawned against the old object. But at 48 I discovered for the first time, because I never used this pattern here, it's not very common, but I discovered for the first time that in mutex, POSIX mutex specification, you cannot unlock a mutex from a different thread than the one that locked it. Okay, so it is designed to protect sections in specific threads where you do lock and unlock, and you protect a critical section. But it is not possible to do differently. But it's a shame, because it's very cool that you lock the object, create the thread, and then you are sure that the object is locked atomically, whatever it takes, whatever time it takes to create the thread. And fuck, a cat pissed near my door. The smell is terrible. Fucking cat. By the way, terrible. So what I did, I used this thread creation pending. It's an atomic variable. By the way, one of the very cool things about C11 is that when you have atomic variables, you can use the normal operator like plus plus, minus minus, equal, without the macros that were mandatory to use atomic variables before. So basically I increment that I have a pending thread creation. I don't know when it will be able to really acquire the lock. Finally it acquires the lock, and it decrements this atomic counter. At this point, given that I have now this pattern, wait, it's simple like that. Okay, so in this function here, vector set wait all background clients, I can do this trick. If we want to wait all the background clients for deletion, okay, then I just do a busy loop waiting for it to drop to 0, and then I can finally acquire my write lock in use, and I just unlock immediately after, and I am sure that at this point basically I have a barrier, and that's it. Okay, just to show you a little better what's happening here. Okay, so imagine that if I have already all clients, all my threads are already running, and they have this in use lock hold for read. Then if I just lock for writing, I'm going to hang here till every thread finishes doing what it's doing. And instead, if and after I wait for the threads to finish their work, I can unlock it. It's it's no longer needed. Okay, so this is a barrier. But if I had an operation that was about to start, so created the thread, but the thread was about to going to lock this object, without that, this is not safe. Because what I'm going to do here is maybe I do that and I acquire the lock, then I release the lock, and then immediately here the thread that was to be spawned would acquire the lock. So it was a problem. Instead, here we wait for all these kind strange conditions, and all the threads that were pending creation will be with the in-use lock taken. Most of the times here this will be 0 thread creation pending. So here you see a busy loop, but it's just the delta that you have between the scheduler and the thread creation. It must be very unlucky to wait any time, and also this requires that you delete your keys as you perform reads, which is something that we must support, because in complicated production systems everything happens. But it's not common, it's not a very common pattern. But you know, the key can have an expired. There are Redis primitives are very orthogonal, but when you combine all them, the implementation can get a bit more complicated. Okay, so what are the alternatives to the solution that I used? So I did this. I asked Claude Sonnet and Gemini 2.5 Pro to do a code review. Both agreed that the solution was sounding. However, I asked Claude Sonnet, what do you think is an alternative to this design? And what it suggests, it's interesting, because it says an alternative to this, which is more complicated but offers some advantage, is that you use an atomic integer in order to ref count your objects. So every vector set has a reference counting. At this point, when you delete your object, Redis objects are already reference counted, but in this case we would have basically this reference counting, which is specific about threading. So basically every time a thread starts to work with an object, it increments the object and so forth. Acquire basically because in this case, when we want to do this kind of reference counting thing, at this point it is possible to do it cross-threading. But this solution would require that the release method sometimes will delete the vector set from the thread. That, in some way it's even better, because you don't pay the latency in order to delete a very large object, because you are in the thread. And actually I may end doing this anyway, but it's a bit more complicated than this one. And since we are very near to the release of the first vector sets, I don't want to mess too much right now, but I will consider this potentially later. However, I don't know, I like it a bit better like that, even if that anyway probably it will be deleted in a different thread, the object. But I think maybe actually Redis already does that. To be honest, I think that sometimes when we detect, I don't remember anymore this thing. Here I am in a module and not in the core, but I believe that the core should be able to do this stuff already. I will check this and understand. Okay, here I didn't ever commit this stuff still, so let's be sure that let's commit it. So don't use cross thread unlocking. Okay, it's a very short message, but then the content makes it relatively clear, I guess. Okay, I will tell you maybe more about how this thing could end in the course of the different revisions, but for now this is enough. And what I really wanted was to have this magic of the low latency, and also note that this thing here, I can run even multiple ones. If I do, okay, I have to copy the command line. It's still too fast, but basically you can have by default 32 or something like that, even if they are very slow. Of course, if you want to write to the vector set, that's a different matter, and you can partially do threaded writes, but till a given extent. But everything is documented in the README, so I hope that potential vector set users will check the documentation, ask me questions, and I will do a lot more video and blog post content soon. Bye.